Rotational kinematics. If you recall, these are the 5 kinematic equations that can be used when motion is linear and when linear acceleration is uniform or constant. Similarly, there are 5 kinematics equations for rotational or angular motion. These equations can be used when angular acceleration is constant. As you can see, the same relationships that exist among linear displacement, velocity, and acceleration also exist among angular displacement, theta, angular velocity, omega, and angular acceleration, alpha. Just as with the linear kinematics equations, each rotational kinematics equation only uses 4 of the possible angular variables. So when you're working on a rotational kinematics problem, write down what variables you're given and what variables you're looking for. Then look at the chart for the equation or equations that contain all those variables. Let's look at an example problem. I coast down a hill on my bicycle without pedaling. When I start at the top of the hill, each bicycle wheel has an angular velocity of 2.5 radians per second. As I coast down the hill, each wheel has a constant angular acceleration of 1 radian per second squared. After 5 seconds, what angle has each wheel turned through, and what is the angular velocity of each wheel? Okay, so what are we given? We have an initial angular velocity for each wheel of 2.5 radians per second. We have an angular acceleration of 1 radian per second squared. And we have a time interval of 5 seconds. And what are we looking for? For part A, we want the angular displacement, and for part B, we want the final angular velocity. So let's start with part A. First, we need an equation. We're told that angular acceleration is constant, so we know that we can use the rotational kinematics equations. So we find this one, which contains all of our given variables and the variable we're looking for. So we just have to plug in our values for omega 1, alpha, and delta t. Then we can use our calculator to solve, getting an answer of 25 radians. And now for part B. For part B, we have this equation that contains our knowns and unknown. Now we just plug in our given values. And we use our calculator to solve, getting 7.5 radians per second for the final angular velocity of each wheel.